All right, so get ready because today we're diving into something pretty wild. Can the universe think?
Oh,
We're looking at this article called Can the Universe Think? And it goes back and forth on whether this crazy idea is even possible. And get this, we're going to be talking about things like wormholes
oh wow.
and quantum entanglement is going to be a wild ride.
I think what really draws people to this idea is that when you first hear it,
Hmm.
it just seems impossible. You think about it, the universe is billions of light years across.
Yeah.
That scale is just, it's mind-boggling. And then you've got Einstein and his theory of relativity saying nothing can go faster than light.
So you're saying if the universe was thinking, it'd be like super slow-mo, right? Each thought would take like forever to go from one side of the universe to the other.
Exactly. That's one of the big arguments against the universe thinking. It all comes down to this idea of locality. Things mostly interact with what's right around them. Like if you had a universe-sized brain, information would have to travel across these huge distances.
Right.
And with the speed of light being the limit, it just doesn't seem likely.
Okay, I'm following you so far. But what about the size of things? I mean, is there like a Goldilocks zone for something to be able to think? Not too big, not too small.
That's a great question. The size of a system really matters when you're talking about processing information. If a system is too big, like a galaxy, it takes too long for communication to happen, nothing can really interact in a meaningful way. And on the other hand, if something's too small, like think about subatomic particles, quarks and all that, they just don't have what it takes to store and process information. Our brains, even whole planetary systems, they seem to be in that sweet spot, the right size where thinking can actually happen.
That's like a computer network. If the connection is too slow, the whole system gets bogged down. And if the individual computers aren't powerful enough, well, you're not going to get very far.
Exactly. It's a perfect analogy. Size is so important when we're thinking of a thinking universe. But here's the thing. There are some theories in physics that might just offer a way around that size problem.
Okay, now you've got me hooked. This is where things start to get really interesting, right? We're talking about quantum mechanics, aren't we?
You got it, quantum mechanics. It kind of throws a wrench into our neat and tidy classical physics. One of the biggest head scratchers is quantum entanglement. It says that two particles, no matter how far apart they are, can be linked. They can influence each other instantly. It's like they're connected by some invisible thread that goes beyond space and time.
Well, hold on. Are you saying that information can travel faster than light with quantum entanglement? Doesn't that go against Einstein's theories?
Well, it's not that straightforward. Even Einstein called entanglement spooky action at a distance. He wasn't a big fan of it. While it doesn't let us send messages faster than light, it definitely challenges what we thought we knew about locality. Quantum entanglement suggests that the universe might be much more connected than we ever realized.
Okay, my head's starting to spin a little here. So if information could be shared instantly across these vast distances, does that mean the size problem we talked about might not be such a big deal after all?
That's a real possibility. And that brings us to another fascinating idea, one that could completely blow the lid off the limitations of distance. Wormholes. I bet you've heard of them from science fiction.
Oh, wormholes! They're like cosmic shortcuts. You can zip across the universe in an instant.
Exactly. Now, we haven't actually found any wormholes yet, but mathematically, they're possible. Imagine the universe is like a sheet of paper. Now fold that paper in half. So two points that were far apart are now touching. A wormhole would be like punching a hole through those folded points, creating a shortcut between them.
So instead of traveling the long way across the paper, you could just go through the hole. You'd basically bypass the speed of light limit. That's
Yep.
incredible. But if we haven't found any wormholes, how do we know if they even exist?
That's a great question. Right now, the idea of wormholes is still mostly speculation, but some scientists think we might be able to find signs of them through their gravity. Just like black holes warp space-time. Wormholes should have a unique gravitational signature that we might be able to detect.
So even though we haven't seen them directly, we might be able to find evidence that they're out there. That's fascinating. But hold on. How does all this connect to the idea of a thinking universe? How do we go from quantum entanglement and wormholes to the universe being conscious?
Well, think about it. If you have the potential for faster than light communication through entanglement, and then you add the possibility of wormholes as shortcuts through space-time, you end up with a universe that's much more interconnected than we initially thought. And if the universe can exchange information much faster than we believed, it opens up some really exciting possibilities. Could large-scale consciousness or intelligence emerge from that?
I see where you're going with this. We started with a universe that seemed vast and disconnected. Now we're talking about a universe that could be buzzing with communication, with information flying between galaxies in an instant. That's a pretty big shift in perspective. But if there was this universal mind, what would it even be like? I mean, how can we even begin to understand something so massive and complex?
That's a question that takes us deep into the realm of philosophy, and it's one we'll be exploring further in the next part of our deep dive.
So last time, we really got into it with this idea of a thinking universe. We talked about how its size and the speed limits of the universe make it seem impossible, but then you brought up quantum mechanics and wormholes, and things got really interesting.
It's a lot to take in, that's for sure. But that's what makes it so fascinating. It really makes you question everything you thought you knew and consider some pretty wild possibilities.
Totally. So we left off talking about how the universe might be more connected than we thought. And that brings me to a question that's been bugging me. If the universe could think, what would it even think about? I mean, our human problems probably seem pretty insignificant on a cosmic scale.
Oh, yeah. Our everyday worries probably wouldn't even register on a universal scale. But remember, we're a part of this universe. We're a product of its evolution. Everything we do, everything we think, even our existence itself, it's all part of the fabric of the cosmos. So it's not crazy to think that our experiences might somehow be reflected in a universal mind. If such a thing exists, of course.
Okay, so our little lives could be contributing to something much bigger. That's kind of a humbling thought. But if we're talking about a universal consciousness, a mind that encompasses everything, how can we even imagine what that would be like?
That's where things get really tricky. We're basically trying to understand something that's beyond our current understanding. Imagine an ant trying to understand the internet. It's just too vast, too complex.
So we're limited by our human perspective. Our brains aren't equipped to grasp something as big as a universal mind.
That's a real possibility. Our brains evolved to understand the world around us, not the universe as a whole. But that doesn't mean we can't speculate. We can still try to stretch our imaginations and see what we can come up with.
Okay, let's do some imagining then. What kind of things might a universal mind contemplate? Would it be worried about the same stuff we are?
Well, that's a question that's been around for centuries. Philosophers, scientists, everyone's wondered about it. Some think a universal mind would focus on the grand patterns of the universe, the birth and death of stars, the formation of galaxies, the fundamental laws of physics that govern everything.
So like a cosmic architect, always tinkering with the universe, making sure everything runs smoothly.
Maybe, or maybe more, like a cosmic artist, creating new and beautiful structures, exploring all the possibilities of existence.
That's a beautiful image. But let's get real for a second. This article we're talking about, it doesn't actually give us any proof of a thinking universe, does it? It's all just theory and speculation.
That's true. We have to admit that these are very speculative ideas. But remember, science is all about discovery. Our understanding of the universe is always changing. What seems impossible today could be tomorrow's breakthrough.
So we need to keep an open mind, even when we're talking about ideas that sound crazy.
Absolutely. History is full of examples of radical theories that turned out to be true. Copernicus said the Earth revolves around the sun. Einstein came up with the theory of relativity. These ideas were revolutionary. They completely changed how we understand the universe.
Good point. It reminds us that we're always learning new things. So even if we don't have all the answers about a thinking universe right now, it's important to keep asking questions, to keep exploring.
Exactly. Who knows? Maybe someday we'll figure out how to detect or even communicate with a universal mind, if it's out there. That would be a game changer for humanity.
No, that would be something. Imagine the conversations we could have, the things we could learn. But wouldn't that be like trying to talk to God? I mean, wouldn't a universal mind be so far beyond us that we couldn't even understand it?
That's a question that takes us into some deep philosophical territory, and that's a whole other conversation.
Right. Maybe we'll save that for another deep dive. But I think we've covered a lot today. We've explored the possibility of a universal mind, tried to imagine what it might be like, and even touched on some of the big philosophical questions.
It's been a really thought-provoking conversation. And in our final part, we're going to shift gears a bit. We'll explore some practical ways you can continue to learn about this topic and delve deeper into the mysteries of the universe.
That sounds great. So for all you deep divers out there, stay tuned for part 3. We'll give you some resources and tools to continue your own exploration of this fascinating topic. Okay, so after that last conversation, my mind is still blown. It's incredible to think that the universe could be thinking. Like a giant brain out there contemplating things we can't even imagine.
It really stretches the limits of what we think is possible. And even if we can't fully grasp the idea of a universal mind, It makes you think about reality in a whole new way and our place in this vast universe.
It really does make you realize how much we still don't know and all the mysteries that are still out there, but it's also a bit overwhelming, you know? Where do you even start if you want to learn more about the universe?
That's a good point. It's easy to feel lost when you're dealing with something as big and complex as the cosmos. But that's where the article Can the Universe Think comes in. It actually gives some great advice for anyone who wants to explore this topic further.
Really, so it's not just a theoretical discussion, it actually gives you practical steps you can take.
Exactly. It encourages readers to dive into the world of quantum mechanics, which, as we talked about, is really at the core of these mind-bending concepts. The article recommends checking out some interactive courses and online resources, things that can make these complex topics a little easier to understand.
That makes sense. I'll admit I was a little lost when we were talking about quantum entanglement and wormholes. It would be great to have some resources that could break those concepts down.
Oh, there are some fantastic resources out there, and a lot of them are free or super affordable. You don't have to spend a ton of money to learn more. You can find lectures from top physicists, interactive simulations that let you experiment with quantum phenomena, even online communities where you can chat with other people who are interested in this stuff.
Wow, that sounds like a great place to start. Do you have any specific recommendations for our listeners who want to learn more about quantum mechanics?
Absolutely. If you're just beginning, Khan Academy is a great resource. They have a whole section on quantum mechanics that covers all the basics. It's a really clear and engaging way to learn.
I've heard great things about Khan Academy. They make learning so accessible. What about people who want to go a little deeper, explore some of the more advanced stuff?
If you're ready to dive into the deep end, I highly recommend MIT's Open Courseware. They offer free access to tons of courses, including some awesome ones on quantum physics and relativity. It's like having an MIT education right at your fingertips.
MIT OpenCourseWare is amazing. I've used it myself to learn about some different topics. It's incredible that they offer all that knowledge for free.
It really is. And don't forget about books. There are so many great books out there on these topics, from introductory guides to more technical stuff. You're sure to find something that fits your interests and knowledge level.
Books are awesome. I love getting lost in a good book, especially one that teaches me something new. And for people who prefer to learn visually or by listening, there are some amazing documentaries and podcasts out there too.
Definitely. Documentaries can be a great way to visualize complex ideas and hear from the leading experts in the field. One of my favorites is Cosmos, a space-time odyssey, hosted by Neil deGrasse Tyson. It's a beautifully made series that explores the wonders of the universe in a way that's both informative and inspiring.
I love Cosmos. It's a classic. It does such a good job of making science accessible to everyone.
And of course, sometimes the best way to learn is just to go outside and experience the universe firsthand. Go stargazing on a clear night, visit a planetarium, or just spend some time reflecting on the vastness of space. Those experiences can be incredibly powerful, and they might just spark a lifelong passion for learning.
You're right. Sometimes just looking up at the stars and realizing how small we are, it fills you with this sense of wonder and curiosity. And that curiosity is what drives us to explore, to learn, to push the boundaries of what we know.
Exactly. The universe is full of mysteries waiting to be discovered. And who knows, maybe one of our listeners will make the next big breakthrough, the one that changes our understanding of the cosmos forever.
That would be amazing. Well, I think that brings us to the end of our deep dive into the question of whether the universe can think. We've explored the arguments for and against it, thought about what a universal mind might be like, and even given you some ways to continue your own exploration.
Remember, the pursuit of knowledge never ends. Keep asking questions, stay curious, and never stop exploring the wonders of this incredible universe.
Thanks for joining us on this deep dive. We'll see you next time for another fascinating journey into the unknown.